does this look right to you guys? So we have 4,000 square feet minus 2 times 3.67 times the 66.67. That was the other area of the room. So this is how I got that. Do you guys agree with that number, 466 people? Okay, I'm going to take that as a yes. I'm going to go on to the next one. So for that same room, we're now going to calculate the exit widths. So how do we get those exit widths? So we're going to go back to, we now know we have an occupancy of 466 people. We also know that if you have more than 150 people, we have to have at least 3 doors getting you out. So to calculate the exit width, we go to this section right here, and they're going to give you the exit width for your stairways, and they give it to you both for a sprinkled building and for an unsprinkled building. So if our building were not sprinkled, they first start off with the tougher one. They say 0.3 inches. But if you have installed a sprinkler system, you can use 0.2. And they call that the exception. So they first call out the 0.3 because they're assuming, well, you don't have to sprinkle your building. We don't require you to do that. That's the tougher one. And then they call this one out as the exception. It's less tough. You can have less exit width that way. And then down at the bottom, other egress components. This has to do with doorways getting out. If you have sprinkled it, it's 0.15 per occupant. If it's not sprinkled, it's 0.2 inches per occupant. So we're using the 0.15 per occupant because we're assuming that it's been sprinkled. So let me see, I did this a while ago, so I think we may need 3 doors in this space, so I'm just going to go ahead and change this to 3. And will that be, what, 108 inches?
Yes.
Oh, I know what's going on. So this is actually, we have 466 people. Yasmin, do you have a calculator on you since you're right there?
Yeah. Yes.
Okay, what would that be?
I got 216 because I got 72, and then I just multiplied it by
3. Okay, so what's 466?
Oh,
0.5. Can you do that for me?
Yeah, it's 69.9.
69.9. Okay.
Mm-hmm.
So the reason I got the 36 doors is because this is your typical door. Now, in public spaces, that's what we use. You can go smaller than 36 inches, but that is your typical door. So what we're asking is this what you're providing? So I've called out, yes, a 36-inch door. You can go down as small as, I think, like 32 inches. I'll have to look at the code to be sure for handicapped accessibility. You can't go any smaller than that. But 36 inches is typical for a public space. And if you have a double door, you're going to have a 6-foot wide exit. So what did you get, Yasmin?
I just doubled it. I put 72, and then I times it by 3. I had like.
You didn't get the 466.
I did. I got the 466, but I put double doors. Is that okay, or?
Yeah, double doors is fine, except for the fact that we're over 150 people.
Okay.
So,
no, like I put double doors and I put 3 of them.
Oh, 3. Okay,
yeah,
sure.
Yeah.
Yeah.
So yeah, the total became 216 instead
yes,
of.
that's perfect then. So as long as you've covered that number right there, you're good to go. So if you have 3 sets of double doors, that's fine. You just got to get above that minimum number. I see what you're saying now. Any questions on that, guys?
Yeah. Why did you use 0.15?
I'm sorry.
Oh, sorry. Why did you use 0.15? Wasn't it supposed to be 0.2?
Why did I use 0.15? Let's see. So 0.15, that's the exit width. We're not at the stairs yet. So the 0.15 is because they have 2 things you have to calculate. One is for the stairways, which is up here at the top, and the other one is down here for other egress components. That's like hallways, corridors, things like that, and doors, getting you out, other egress components. So down here it says 0.2 if it's not sprinkled. Can you see my cursor, sir? That's 0.2. But that's just standard. Let me see if I can slide this all the way over so you can see that whole slide. That's just standard. That's where the 0.2 comes from. If we sprinkle the building, those other means of egress components will be 0.15 per occupant in buildings equipped throughout with an automatic sprinkler system installed. So we're going to calculate the stairs in a second.
Yeah, I was just confused because you talk about the stairs, so thank you.
Okay, so this is exit widths in general right here. And then we go down here and we do total stair widths.
Professor, I'm sorry, I had a quick question.
Uh-huh.
So, okay, do we need a minimum of 3 doors? Because, so 2 doors would also meet the minimum of, like, the 69.9. But there's a reason we're using 3 doors instead of 2, right?
Right. There's a reason I'm saying 3 doors instead of 2. If you all remember when we did the, and that's a very good question. Thanks for pointing that out. So let me see if I can do it like this. So if you guys remember, we had this diagram when we had fire safety laws. And we said that those exits had to be apart at least 1/2 the diagonal of that room. So up to 50 people, you can have just 1 door. But if you get up to 50 people or more, you have to have a minimum of 2 doors. And the distance between those 2 exits has to be at least 1/2 the diagonal of that room. But when we get up to 150 people or more, we have to have that 3rd exit. So that 3rd exit, I'm going to end up putting somewhere over here, or maybe here in the middle, because I'm still trying to get that 1/2 of that diagonal distance right there. So
okay.
you do need, when you get up to 150 people or more, you are going to need that 3rd exit. Now, they can all be double doors, which is what I think Yasmin was saying she had. Was that correct, Yasmin?
Yes.
So Yasmin's being extra sure people can get out. So let's look back to our own example. I don't know if you guys, if you can visualize in your mind's eye, if you can see our auditorium space. So I know this is not the same proportions, just imagine that this is longer. In our auditorium, where I normally teach this class, there's an exit over here on one side of the room, and there's an exit over here on the other side of the room. Down towards the front, though, so let's say this is the stage, there's another exit over here, and you'll see the exit sign on it, and it's just a single door. And, you know, it pushes outward, and it's an egress door. So I'm just imagining in my mind that the architect, well, these are for public use all the time. As like large students, it would be a jam if this was just like a single door getting people in. He probably could have met the requirements for egress without having these be double doors up here. But then for fire safety, he had to have that 3rd exit. So that just need to be a double door because that's just for fire. Nobody goes out, and I've never, unless there may be a fire drill or something. But even then, I've never seen anybody go out that door. So that's just a single door because that's only for emergency use. So you still have to have those 3 exits. They could all be double doors. This could be a double door too, but it doesn't have to be. Does that help answer your question some? Who's asking? Was that Adrian?
Yes, thank you so much. I appreciate that.
Yeah. Okay. So Yasmin's just going to make sure everybody gets out. She has 3 big double doors in her space. Everybody has an easy way to get out of that space. So now total stair / corridor width, so I guess including corridors with that, is 0.2 inches. So we go back up to that earlier slide again. Where did I get the 0.2 inches from? There it is here. Because, again, and per occupant in buildings equipped throughout with an automatic system installed. If I had not installed a sprinkler system, it would have had to been 0.3 inches, but it's 0.2. So that's my width of the, and here's the thing that threw me off when I first started looking seriously at codes. You see that little word total stair width? So you can imagine in our own building at the college, we have more than 466 people there a lot of the time. Well, certainly on graduation day, I don't know, like about on a Tuesday or Friday when there are not many studios. But you can imagine we have those numbers of crowds. But if you notice, we do not have a stair that is 90 some inches wide. That is the total stair width. So remember, just like you have to have 2 ways out of that room, you also have to have 2 ways out of a building in case of a fire. So the same principle applies at the scale of the room as it does at the scale of the building. So I have to have 2 stairs in our building. They're on each end of our building. So our building is kind of rectangle like that. We have a fire stair over here, and we have another fire stair over here. So we have double doors here. Put a nice double doors here. We have double doors here. We also have another exit over here by the loading dock. No, I'm not drawing that, but that's the diagram. So everybody on that ground level can't go through the library over here, but everybody, if you're on the ground floor, they have 3 ways out of that space. Everybody upstairs has 2 ways via the fire stairs. They can get out. And the same principle applies at that scale of it's got to be half the distance, a minimum of half that diagonal. And we more than cover that in our building. So one easy way to remember it is that the scale of the room and the scale of the building, the same principles apply. But they're asking me and asking us for, well, what's that total corridor width? So let's go back to another rule that's in place that relates to this, the egress. So remember we were talking about egress, and that egress has to be 44 inches or 3.67 feet to get out of a room. That's the minimal requirement for the building as well. And for the stairs is 44 inches for any stair. If it's sprinkled, it's 44 inches. If it's not sprinkled, it's actually 48 inches. Here's why we use 48 inches here. The 466 times 0.2 equals 93.2 inches. I think I went over this a couple weeks ago. So now If I had two 44-inch wide stairs in our building, and I'm just going to draw that real quick for you as well. So if each of these stairs here, if that one was 44 inches wide and this one was 44 inches wide, because they're asking me for the total, that's 44 there. And if this one over here is also 44 inches, I shouldn't be drawing it like that. Actually, it's like this. That's the width of the stair. That's the whole stairwell. So if I'm providing you with a 44-inch route over here going down and a 44-inch route over here going down, that's going to give us a total of how many inches going down for the entire building?
88.
88. So that doesn't meet that minimum requirement of 93.2. I suppose you can do it. I haven't seen it not, written anywhere that you can't do it. I suppose you could make some odd stair like, and have a 94-inch stair or something like that. But we typically work in things like 44 inches and 48 inches. So to cover that 93.2-inch total stair width, say we're going to provide a 40-inch wide stair so that the width going down this stair here, all the way around, is going to be 48 inches. So now my total width of stairs for the whole building now is going to be 48 plus 48, which is 96, unless I'm wrong. So the total stair width, I should rephrase this down at the bottom, should actually be something more like is 93.2. So each stair is 48 inches. So I'm providing them to cover that, to get over that, I'm giving them the 96-inch stairs. 96-inch width, total width. A lot of silence out there. Remember, you're going to have to calculate this next year for your own buildings. So please do ask now. That's why I'm doing this. And you can help me clarify my own thoughts by asking questions. Clarify my slides. So we've done one. We've done this. Let's do another one. There we go. Make this smaller.
I have a question.
Mm-hmm.
So, is it the same with the stairs as with the doors for egress? Like, if you have like 150 people, you need like 3 exit ways. Do you also need different, like, separate stairs for different people, or just one? Like, if the building has greater capacity but isn't like as big, do I still need like 2 stairs, or can I get away with one, with like a big one?
No, you're never going to be able to get away with one big stair. You're always going to have those 2 ways out of the building. And here's the diagram that I just showed, because I know it seems complicated, but once you understand what the intention is, then it becomes a lot easier for you. You can never get away with having one stair. Code doesn't allow it. It's the same rule. So I have a building right here, and there's fire that comes up right here in the middle. What the codes are trying to do is to allow people on this side of the room to get out without having to go through the fire, and these people can go outside. So that total exit width, so you can't just have one big 96-inch wide stair. No. Does that answer your question, Sarah? You have to have those 2 fire stairs, and the reason why is they're trying to say, and the test I've been giving my students, we've been placing fires all through their buildings this semester, I'm like, okay, how do I get out of the building? There's a fire here. How do I get out of the building if there's a fire here? And that's also where they have that rule. You can't have more than a 20-foot dead-end corridor because they think a person may, if there's smoke everywhere, start going down a corridor and thinking it's a way out, and they're trapped. So you can't have a corridor that's longer than 20 feet because you can walk 20 feet and then turn around without too much damage being done. So we've actually had students rearranging or reconfiguring things because a person who's familiar with the code, they're going to flag that right away. And they should, because at the end of the day, the ultimate goal is to protect human life. So just like the doctors have this code, first do no harm, that's why all these experimental treatments and things like that, if you're on your deathbed or you're going to be terminal, they'll try them. But if you have, they're not going to experiment on you. So the first law in architecture is not really, oh, we want this really elegant, beautiful, amazing design. We want to preserve human life. And that's why all these laws are there. So you have to have those two fires out, two ways out of the building, for a building of a certain size. If you have a one-story building, and then there's some buildings that have been grandfathered in. I know there's a death trap over in Montrose that I've told you about, but because this was built, I've forgotten what year, but it's been up there for a while, before all these codes were in place, they don't make you go back and rip it out. So I guess buyer beware when you're visiting, spaces like that. So Sarah, does that answer your question anyway?
Yes, thank you.
Okay, let's work out another one then. So the lobby, again, please do check my math. I was a reader and a drawer. I was artistic like most of you. Math was never my strong suit, and yet I ended up at Georgia Tech. So lobby, 700 square feet. We ask you, what is its classification? I've shown that at 8.3. What is its requirement? We all said that's 7 net. So I simply took the square root to make a nice shape, but you can do your own. The answers should come out very close to mine, but as long as you can show the reviewer this information, that everyone is getting that 44 inches out all along that perimeter right there, then they're saying the goal is that you provide that perimeter of egress for people to get out of that space. So you don't have to use this formula. If you can graph this if you want to, but however you want to come up with that, I got there. And here's something else I should point out. I calculated 52.4 there. So I went to 52. Who remembers why I did that? Gaston, are you there? I just saw your name earlier. Why did I do 52 occupants instead of 53? Why didn't I round up to 53?
It's because
this is telling me how many people I can get in that space. I can get 52.4 people in that space, but I round it down instead of up. Why?
Because 53 will be over the total occupants.
Right, exactly. 53 people can't split the baby in half, and 53 people would get me over. So we round down instead of up. When we get to calculating our plumbing fixtures, we're going to round down because, again, you can't split the baby in half. You can't have 1.5 sinks. So if code is requiring 1.5 sinks, you have to provide 2 sinks. If it's asking for 4.5 commodes, you have to provide 5 commodes, because 4 commodes won't meet the code. So as long as you're meeting the code, that's what this is doing. So this whole little exercise is say, okay, I get the basics of the code. I know how they're getting the answers. I can calculate my own. That's why we're going through this. And then next year you get to practice for yourself. So I did the same thing. Yasmin, can you check my math here? Does that look right to you?
I checked it and I got 341 instead of 367.
I got 52 for the total occupants. I got that as well.
For the lobby? So Sarah, how'd you get 300 and something people for the lobby?
No, 350 people. Like the number that you have, 367.
Oh, that's square feet. Oh, you're telling me you got a different number there.
Yes, I got 48.8 people.
Okay, then that's fine, because that's going to depend a little bit on the configuration of your room too. So there's going to be some variation there. But remember, when the reviewer is looking at your drawings, he's going to be looking at your configuration. And typically what people do now when they take things on the computer up there, they have this path marked out for the reviewer. That's the beauty. You guys don't know how lucky you are. You can literally just inscribe this on the plans inside the rooms if you want to. So the reviewer can really do the fast checking. And the reason that helps you is when you take it into the reviewer to get it checked, these are not checked by computers, these are checked by people. You know how when we're designing, when you go to a review or something and your drawings are nice and clear, people kind of give you the benefit of the doubt and think you know what you're doing. It's the same thing. If you make your answers really clear, if you go in there kind of sketchy and they have to look for stuff and look for answers, they're not going to give you as much benefit of the doubt. But at the end of the day, the goal is for you to provide egress for people. Because this goes through a lot of hands. Even if you get it permitted and the fire marshal comes by and he doesn't like what he sees, he's going to shut the building down. That's why we have the fire marshals and Professor Kirkland. Do you guys remember Professor Kirkland? Was he around when you guys came in? I don't think he was retired then.
I remember him.
You remember Professor Kirkland? He used to coordinate first year, and one of the things he used to do when the fire marshal was coming around, students would bring sleeping bags in, and they'd be sleep. That was a definite no-no. This is not a residential facility. He would come around and have us move stuff all the way to the back. Students would have decks blocking this route right here. He would get very angry, and the instructors, I know I was one of those doing that myself, having to pull desks out of that egress. We will get flagged. That's why Maria during graduation is taping that off. You will get cited for this and have to pay fines and stuff. So even if you get permitted, the fire marshal goes around all the time doing, spot inspections basically. So the process is the same. 52 people, 0.15 to get the exit list for the doors. So we're not going to give anyone that amount. So I remember, I think it was Yasmin saying before, she's getting these ridiculously low numbers, which you do sometimes. But we know we got to provide them in another part of the code at least 2 ways out. Or actually, got to provide them at least 2 ways out because we have 50 people in that room. So my typical door, standard door, like in the architecture building is going to be 36 inches wide. That's going to give you 72 inches. That's way more than that 7.8. So you're good to go. Here, for this lobby, tiny lobby space, it's only requiring that. But here's the funny thing. That 48 inches is going to go throughout all the buildings. So I'm asking you to calculate these room by rooms, just like you're going to have to do next year. But you're not going to have more than one fire stair. And that fire stair width is going to be the same all the way down. So you're going to go through this calculation for every room, But the fire stair you're providing is going to link all those rooms vertically. So that same standard width, so it's going to be calculated basically for the largest occupancy. And then next year you're going to just do it floor by floor anyway, because what we're really getting at is how many people are there per floor. But we can't really do that until you actually design the building itself. So right now we're just calculating it room by room, but if you look at the example I gave you, you actually have to calculate it floor by floor because they're trying to get a maximum occupancy for each floor that they're then going to connect vertically with the fire stair. And they're saying, oh, got to have this minimum amount of width for people to get out, total width for the whole building, and then I'm going to have one fire stair, and that 48-inch width, we calculated based really on that 466. That's our largest occupancy. But at the end, I'll go back and I'll show you the students that are calculating for 4510 because now their plans have been designed. So now they're going back and doing all of this for each of those rooms, but they're doing it floor by floor to get the occupancy exit widths for those stairs. Because if I have 500 people on one floor and 200 people on one floor, which floor do I have to design for?
500.
The 500, right. And the 200 floor gets the benefit of the same. So it's the same principle, so I'm getting close to 9:30 now. I'm going to upload these and Dropbox. Don't just mindlessly copy these because remember, I may make a math error. So I would go back and calculate these for yourself. I'm going to go back and double check these for myself, but I have at least shown the process. Here's one we need to talk about real quickly though. Remember the collections right there, that reading area? So I went back to the code all the way up to where is that here. And remember that collections was 50 net and 100 gross. 100 gross for the stack areas and 50 net. So we had this collections area, and I remember Yasmin asking me this earlier. Let me see if I can find that slide. That's the classrooms. Collections. And did that one separately. So for the collections, you have to calculate them separately. So 4,000 square feet for the reading areas, and that's going to have a net value. And then the stack area is a different value. So I calculated those separately and got a total occupancy for that. The gross area calculation was easy. You just divide that 9,000 by 100, that's easy. So I calculated the net value, which I got up here for the reading area, added that to the 90, and I got 152.62 occupants. I had to round down because that's the number of people. Because if I had 153 occupants, I'd be over. Okay? Then I did the same thing with the exit widths and the corridor widths. Got this really low number right there, 10.48. So I already know anyway I'm providing 48 inches coming down because of the urban room. So they're all going to be 48, no matter what number I get right here. And it's able to be 48 and not 44 because the building is what?
Sprinkled.
I'm sorry, it can be 44. I'm sorry, I had a mismatch of words, as Hillary Clinton would say. I'm doing this because of that urban room. It's 44 if it's sprinkled, it's 48 if it's not sprinkled. Sorry, mismatch of words. I'll use Hillary's excuse. So classrooms, conference room has 20 net. I just did the same thing. 63.24 by 63.24, 4,000 square feet. And I got 139 occupants. Depending on your arrangement, you might get something a little bit different. But if I'm taking these plans down there, this should pass. Assuming my math was correct right here, that should pass code. 139.
Professor,
Yeah.
a quick question. So for the perimeter, like 44 inches, so where you get the 3.67 from, like the P for the P?
Where did I get that from?
Yeah, like.
That 44 inches is from code. That is the minimum width for any egress space, corridor, or stair, which is a question I just had Yasmin asking why did I have the 48, and I mixed them up. The 44 is the minimum egress width you can have in a sprinkled building. That's where the 3.67 comes from. That's according to code. I can go back to the code. I'd have to go back further down, and I can see if I can find that for you. But we were all looking at that a couple of weeks ago for 4510, and the 44 inches, I don't know exactly where it is in code. I have to go and find the pages, but that is straight from code. For a sprinkled building, that's the minimum width. For a non-sprinkled building, is 48. Over here, when I was just asking Yasmin why we had that 48 is actually because of this occupancy requirement right here from the urban room, where we had to have that total width be more than 93.2. And if we had 44 inches for the stairs, that would get us to the 93.2. But that 44 inches is the minimum width, egress width in a sprinkled building. And that is straight from code. Okay, so did that answer your question? I don't have
Yes,
the code here.
Yeah, I do understand the 44 inches, but my question was the 3.67 on the form.
Oh, 44 inches. I just took 44 inches and divided that by 12 to get it to
By
feet.
12.
Yeah. So that was just my conversion of 44 inches to feet. And it's 3.66666, so I just said 3.67.
Okay. I see now.
That was just the conversion so we were in the same units, because I'm dealing with feet here and B and H, so I still have to deal with feet in the perimeter. All the units have to be the same for the mass to come out. Does that make sense?
Yes.
Okay.
Thank you.
So I'm just going to quickly, I'm going to upload all these slides after class today. Oh, if only we had more of these, right? Gross is simple. So they're assuming that in these administrative offices, there are going to be fewer people. So these are not large assembly gathering spaces where you have a lot of people at one time. So you can just divide that by the gross value. So, but life wouldn't be fun if it weren't a little hard, right? So I want to quickly go down to, so I have time to go through the plumbing one. So this, remember I told you, if you're ever doing, Excel can be your best friend. But where we got those plumbing codes from, you then have to go to the plumbing code sheet. And for our assembly spaces, we were using A3D. So you see this right here where it has libraries. So that's why we're using assembly A3D. And then you go to the right and they tell you for men, 1 per 125, for females, 1 per 65, lavatories, 1 per 200, no bathrooms or showers, and for fountain, 1 per 500. And then 1 service sink. We're not asking you all to look at that. And then for businesses, fleet classifications, 1 per 25 for the first 50. And that's for men and women. You see that right there. And then lavatories, 1 per 40 for the first 80, and 1 per 80 for the remainder seating. It gets to be tedious, right? That's for men and women. And then 1 per 100 for water fountains. So the only trick you have to remember, so I took all that information, and this is just a little spreadsheet I had made when I had a different program, and I just went back and all the numbers. But I actually had it my husband wrote a little computer program so I could just plug all those numbers in. This is why Excel will be your best friend later on one day. And I'm still trying to, really learn how to program Excel in a meaningful way. But that's another skill architects will find very handy. So I just took this is like my little worksheet. So we're asking you to format yours like this. So that's how you're going to format it. You're going to tell us how many were required for that space. So water closets required 1 per 125, and then this is the number you're providing over here. But this is my little worksheet. So I just went back up to the table. So the first thing that I did was I went back to all of our occupancies, and I just plugged those numbers in over here next to the room. So I just made my own little worksheet because it is tedious. And then we do ask you what kind of space is it, just for clarification. This is kind of an assembly. A portion of the collections is assembly. You can break this one down if you want to, but I'm not requiring it. You could break this one down because there's actually one for storage too on here. I think I may have cut it off. But you really only have to calculate this as well, the collections area. They're going to be slightly different for the storage than for the assembly areas. But we already had that accounted for that. So that's going to be our total occupancy of 152. But if you really wanted to be maniacal about it, you could just break collections down for the plumbing as well. Because there's going to be a different requirement for water closets for storage areas. So you could say, I'm going to do the books separately. But we had already broken down the total occupancy for the collections, and we got 152. So for our purposes, we're just going to go with 152, and I'd be willing to bet the permitting person would too. And then we take that total occupancy, and for the water closets anyway, that's the commodes, you have to divide that by 2. So we're just going to say, I'm imagining that I'm going to have 233 men and 233 women, that men and women are going to be equal in this facility. And so we just take that occupancy, we divide it by 2, and that's where I got that 233 from. Then I know that according to the code that we just looked up over here, 1 per 125, for men, I take that 233 and I divide that by 125. Then I do the same thing for the females, only they require 1 for every 65 people. I guess women are in there putting on their makeup, and that doesn't really affect the water closet, but you get more water closets too. And so I take the same number, so I'm going to have more fixtures required for females than I will for the males. So that's here. Then I go over here. This is just for my own worksheet purposes. Lavatories are 1 per 200. I did not write that. Yes, I got that 1 per 200. Then I take that 233 and I divide that by 200. Let me see if that looks a little high. So I may have that 1.86 incorrect. So 200 divided by, 233 divided by 200. $1.16. Yes, I'm glad I caught that. Thought that number looked high. That should be 1.165. Oh, that's a wrong number. No wonder that's there. I had that right. I did get it right. Yay. Yay me. That number is over here. 1.165 for men and 1.165 for women. So I did get the lavatories correct. For the water closets I took this number over here, 233 divided by 125. That's where the 1.86 came from. The 233 divided by 65, that's where the 3.58 came from. So then over here though, how many water closets do you actually provide? Well, I can't give men 1.86 commodes, so I give them 2, and women instead of giving them 3.58 commodes, I give them 4. So this is that number that I had calculated for the lavatories. So I took that same number, the 233, divided that by the 200, and that's how I got the 1.165 here and here. So lavatories, fancy way of saying sinks. Water closets, fancy way of saying commodes. So I'm going to give 2 sinks and the lavatories, and I'm going to give 2 sinks to the women.
I have a question.
Uh-huh.
So it's okay if I just increase the laboratories and the water closets provided. Let's say I put like 6 instead of 4 for a female and 4 instead of 2 for a male.
Yeah, as long as you give me this number right here, the number that's required. So if we go over there and you get that correct, so over here you're telling me how many is correct. So yeah, you can just give me however many, as long as you're over that number.
Okay.
What I'm looking for is that you receive that number. But do this math, that way this is giving you the minimum number. Now, what most people find is that these are never enough. And that's why you see long lines of women standing outside of the restrooms at intermissions everywhere. And as an architect, you just have to account for that. So the same thing for the lobby. Let's look at one that's a little different down here. The classrooms, the educational space, E. So let's go back to the code, look right here. Classrooms are here. So for men and women, it's 1 per 50. Scrolling up to the top. The sinks are the lavatories, also 1 per 50. So our math is going to be pretty easy there. So I calculated 139 people for the occupancy. So I'm going to divide that by 50. And I got, divided by 2 first. And that's how I got the 69.5, half men and half women. Divide that 139 by 2, got 69.5. And then that's the number I'm going to divide by 50, 69.5. And that's where I got the 1.39 fixtures from here for men. And the same thing, 69.5 women divided by 50, 1.39. And they require the same thing for the sinks. So I got 1.39 all the way across because I took the number, divided it by 2, so I have 1 set for men, 1 set for women. And that's the trick here, getting to the 69.5. And from there, I got divided it by code requirements of 50. And it makes sense that it's the same all the way across because it's the same all the way across here. 1 per 50, 1 per 50. And then for the water fountains, 1 per 100. Now, I'll tell you the truth. You're probably not going to calculate it like this. You're probably going to do it for the whole building. We don't have just one set of restrooms on one floor or for one space or for one room. So probably we only design 1 set of commodes for the whole floor. So once you actually design your building, you will go back and double check and make sure that you have enough commodes for that entire floor. So typically in any building that's more than 1 story, most buildings have some sort of core where they have plumbing, your elevator, and your bar stairs, sometimes those are thought of as core elements as well, and they thread through the entire building. So just like we only provide one bar stair per floor or two bar stairs per floor, we only provide a couple set of commodes, one for men and one for women per floor. So we're going to add, in real life, we're going to add everything that's on one floor together, and then we're going to decide, then we're going to come up with how many sinks and commodes. We're not going to do it room by room by room. But you haven't designed this space by now. So now you're showing us that you can calculate it room by room to get to that floor by floor information. So if I go back to this one over here, because I just have a